In example 5, we want to consider the integral of e to the x times cosine x. Now this doesn't fit the standard pattern of a power times an exponential or a power times a trig. It's an exponential times a trig, but this also can be found using integration by parts. I'll just kind of give a heads up here. This is kind of a long example. It's a difficult one, but it's important to see this process because it gets used in later math classes like differential equations. So the idea, so it's an important idea. So I look at this and we want to pick our u and our dv here. So let's see, doing a integration by parts, so u and dv, and then du and v. And here you want to pick u, so it's got a simpler derivative. Well, you differentiate e to the x, you get e to the x. Not simpler, but not harder. If you differentiate cosine, you get negative sine. Yeah, that's about the same, not harder. And then you want to pick dv, so it's easy to integrate. Well, integral e to the x is e to the x, and integral cosine is sine. So it looks like our general rules of how to pick u and dv don't give us a whole lot of guidance there. Let's go with our first choice. U equals e to the x, and dv is cosine x dx. And let's just see what happens. So du then is going to be e to the x dx. And then v, the antiderivative, will just be sine x. So we're going to do the product on the diagonal minus the integral of the last row. So our uv is going to be e to the x times sine x minus the integral of v du. So that's e to the x sine x dx. So we look at our new integral here, and it's not really easier than the original integral. It's about the same. But let's see if we can find this integral using integration by parts, and then we'll plug the value back in. So let's do a separate problem down here. Integral of e to the x sine x dx. And let's let our u be e to the x again, and our dv now, sine x dx. So we need du, which will be e to the x dx. And then we need v, antiderivative of sine is negative cosine x. So then uv minus integral v du. So we got that product minus the integral of the bottom row. So uv will be negative e to the x cosine x. And then minus integral of v du, the bottom row, which would be minus e to the x cosine x dx. And then this double negative will make a positive. So we can simplify that a little bit. And then this expression for integral e to the x sine x right here, we'll go ahead and plug that in right here. So in the next step, this will be e to the x sine x minus this whole expression, minus e to the x cosine x plus integral e to the x cosine x dx. And let's go ahead and remove the parentheses and change the signs here. So this will be e to the x sine x, double negative there, positive, plus e to the x cosine x. And then this will change to a negative, integral e to the x cosine x dx. So after two integration by parts, we've got products here of exponentials and trigs. And then look, we've got this same integral back that we started with again. So in other words, here the integral of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x, and then minus integral e to the x cosine x, oops, I forgot my x in there, dx. So now notice we've got this same expression on both sides there. So those are like terms. It's like solving an equation where this whole expression is the variable. So what we'll do is we will bring this over on the other side as a positive. So we'll have e to the x cosine x plus another e to the x cosine x will equal 2 of those integral e to the x cosine x's dx. And then I've got these two terms left, e to the x sine x plus e to the x cosine x. And now we can solve for the integral that we want by dividing a 2 off on both sides. These guys cancel, and the integral of e to the x cosine x, right here, we got it. And for our final integral, then we'll go ahead and add that constant, plus c. So here, this was 2 integration by parts, and then solving an equation when we got done. So that idea of 2 of the same process, and then you get an equation involving the expression that you want to solve for, that's the idea that comes up more than once in later classes. So I want you to see that. I'm not going to put any problems like this on the exam though. Too much for an exam. But interesting process.